Hey everybody, this is the first episode in my new series in which I'll be going through a collection of physics questions about concepts from a fairly extensive textbook that I used in my AP Physics class back in high school. I'm in college now and I'm majoring in physics. That's where I'm filming this from right now, actually. And I've decided that not only will making videos in which I explain these problems not only help other people, but it'll also help myself, since I find that explaining these sorts of questions helps get them stuck in my head a bit more. Anyway, this first question I'll be going over asks, pretty simply, what are the merits and drawbacks of using a particular person's foot and any foot as a standard of measurement? Now what this means is it's basically referring to the pros and cons of standard, meaning the measurement quantity is based on a specific object. To make it more clear what exactly I mean by that, a famous example is the kilogram, which is a unit of weight. And for the longest time, up until recently in fact, I think last month it was actually when it finally changed, the unit of the kilogram was actually based on the specific weight of a specific slab of metal that is now stored in a French museum, I believe, where the definition of a kilogram was like the literal scientific definition was based on the weight of that object. Now that's not the same anymore, and this question is meant to help us understand why that might be the case. Because in this case, we're given a foot. And, well, the merits of using a particular foot as an example, well, of course, it's reproducible in the sense that if you have that based on a specific foot, that means that, well, it's not going to change too much and that you are going to have a means of going back and using that same foot if you need it. But the problem with that, in terms of other examples of using objects as a standard, is the fact that since it's a specific object, that means it's inaccessible because other scientists, or not even just scientists, but people who just want to use it as a reference for their measurement aren't going to have a very easy time doing it because they have to go back to that specific location or they'd have to track down that specific object if they wanted to make sure their measurements are precise. So it doesn't work very well in that aspect. Now, admittedly, using a foot as an example is a little bit extreme because that does bring us some other problems as well, such as the fact that the size or weight of the foot is going to change over time as a person ages. And since feet are not made out of metal, they could break potentially, which could have caused a whole host of problems on its own. But yeah, either way, I still think it's a good question anyway though, because even including these other factors will still help you get into the mindset of understanding what makes for a good scientific measurement or a scientific standard. And as for using any foot, that's even more crazy because although they are more accessible in theory because of the fact that anyone, well, most people have at least one foot, the problem is that's incredibly variable because everyone could potentially have different sized feet, and they're not all gonna, and using any person's foot isn't gonna help you if you want consistent measurements done. Now, of course, the same arguments I use here apply in the sense that they're also changing, and they're also breakable as well. Notice I already have these markings down because this is actually take 2 of this recording, because my camera phone decided to take a dump on me, and my first take wasn't very useful. Hopefully this one comes out better. But either way, yeah, so as you can clearly see, the drawbacks in both cases significantly outweigh the merits of either case. So I'm hoping that'll help you understand why that is, that if you ever look at a textbook, or not even that, but if you ever look up the official SI definitions of a measurement, then it's always something crazy or super specific. Like I believe the SI measurement for a second is like the time it takes for something to oscillate 1,000,000 times between a particle, or so something specific, that's not worth memorizing. And if you ever looked at one of those definitions and thought to yourself, now, why would that be? That doesn't make any sense. Well, this is why. Because if they're not based on extremely specific things that are both accessible and reproducible, then the data is not going to be very good. And that's one of the most important things to keep in mind in performing scientific experiments, that you're not getting horrible, unusable data. So I'll let you think about that if you want. That's it for this video, though. I'll probably make another one shortly. If you like this video, feel free to comment or ask me to do a specific question that you want to see. Or subscribe if you want to see videos similar to this one. See ya.